The mass spectrum of the chromate ion is shown below, and assume that only the most common oxygen isotope exists in the ion. And part A asks us to calculate the average atomic mass of the chromate ion, which can be done using the sum of the masses of the isotopes, weighted by their relative abundance. Which gives us the following average atomic mass. Now in part B, we're asked to calculate the number of neutrons in each chromium isotope. So what we can do is make a table. So first we find the mass number for each chromium isotope. So for this one here, we subtract the mass of the oxygens. Okay, so we have 4 oxygens in each ion. So effectively the chromium isotope in this ion has a mass number of 50, and given that chromium has an atomic number of 24, so that's 24 protons, then we just subtract the number of protons from the mass number to get the number of neutrons. And if you do the same calculation for the other isotopes, you'll obtain the following results. And for part C, you can verify the average atomic mass of chromium using the sum of the masses of the chromium isotopes weighted by the relative abundance. So given that one oxygen isotope exists in the ion, then the relative abundance is dictated by the chromium isotopes. So have a think about that. So I'll leave it for you to verify the average atomic mass of chromium.